If you guessed the DX-60B was the next project, you guessed correctly.
The Navy announces that Wake Island is probably captured by the enemy, and now it is disclosed that fewer than 400 Marines held Wake Island for at least 14 days against heavy Japanese attack.
Good day, and welcome back to Mike's Radio Repair and Restoration. If you were here for our HR-10B restore, we talked a little bit about the history of this radio, and today we have the matching DX-60B transmitter and the matching VFO for it. This setup has its place in history for sure. Even some of our viewers have said, hey, that was my first setup, my first rig that I ran. And it was affordable at the time, and many late 60s, early 70s brand new radio amateurs bought and built the setup, and it was their first time getting on the air, making their first contacts. And many did that. So this has got a significant place in history, this setup. So this particular series of videos, we're going to be restoring the 60B, and then following that, we're going to be doing the VFO. And at the end of it all, when this is all done and restored, let's put it on the air and make some contacts. I think that'll be some real fun to get an idea of what those early people with the set experienced, and I think that'll be a little bit of a thrill. So the path for the 60B for restoration is going to be a little different than doing a receiver, and it's also has got a high level of danger. There is at least 600 volts plus available on the bottom and top of this chassis for the plate of the 6146B tube. A mistake could very well be lethal. So if you're going to follow along and restore a transmitter or a 60B with this video, you do so at your own risk. You really got to be careful around high voltage. It's getting serious now. I mean, you know, in a tube radio, 250 to 360 volts, that can be lethal as well. It's often not. A lot of people get a learning shock at that level, but you don't want one with this. This has the ability to deliver 250 milliamps or more, which if it gets a good connection, it could well be fatal. So I can't stress caution enough when dealing with this. So we're going to approach this differently. This also has diodes rather than a rectifier tube in the power supply. So how we're going to deal with that is also going to be different. So we're going to deviate off my 5-step course, but it'll be similar, and you can follow along. So in just a second, let's get into our initial assessment. Taking a quick look at the exterior of the 60B, there's only a couple things I notice. It has a 2-pin mic jack, which tells me somebody's possibly done a modification for push-to-talk, as opposed to using the switch here. And the other thing I noticed is the meter face has quite yellowed a bit and not looking so great. So the back is all right. So I guess the next thing we're going to do is we're going to pop the covers off and have a peek, start making up a list of the things that we need. Okay, covers are off. Let's talk about what I know. Not found anything really bad yet, but I found one thing that's a little bit discouraging, but you know what, we'll just deal with it. The what looks like dust on the top of this chassis is actually a light corrosion, and it's almost impossible to get rid of. I've just tried to clean a small spot, and it got better, but it didn't get wonderful. So that's going to be a little bit of a labor, and it's not going to get perfect, but oh well, it's not going to affect the operation of the transmitter. From the top, I'm not seeing anything earth-shattering. It might have flashed over once upon a time in its history And if it did, it wasn't bad. And I'll show you why I think that when we look at the bottom. But what I have done is I have removed the meter. The meter is a pretty critical element to this transmitter, and there are some designed-in problems that can take this meter out when the tube fails, and we're going to go through them. Now, I have already taken this meter apart because it was stuck and it wouldn't move, and that's kind of sort of common for a DX60, is that the central fulcrum gets dry, and all you have to do is put a very tiny little bit of watch oil on each of the fulcrums, and it has come back to life. Now, measuring the resistance across the back terminals, I'm measuring about 51 ohms, which tells me the meter is still good, because in a lot of DX60s, there was an event that would have happened with the tube that cleaned out a resistor, which we're going to look at it in a minute, at the base of the tube, that once that resistor burns up, it puts 250 milliamps across this meter, and as you can see, it says right on it, full scale deflection is only 1 milliamp. So if you put 250 milliamps across a 1 milliamp meter, of course, you immediately burn it. So I'm happy to announce that the meter appears to be saved. However, I do have a spare from another Heathkit product coming. It is a full-scale 1 milliamp 50 ohm resistance meter. The scale is a little different, but it would work, and it's maybe a cleaner meter, so we'll see what happens when that comes. I have all of the tubes out here for testing. I don't know what the status of those is. But so far, looking at the top, I don't see any deal breakers here. It looks like we can go ahead to restore, but it's just a big cleanup job. Let's have a look at the bottom and see what's what down there. Okay, looking at the bottom of this whole girl, it's obviously not been restored. It has some of the original caps here that we can see. Here's a couple of others that have got to go and be changed. So I don't see anything catastrophic or anything missing down here. All of the band switches are good. All of the wafer switches are good, including the main selector switch, which we're going to talk about and we're going to look at in a minute. It's very nice that this switch isn't burned out, because that's another DX60 problem, that cleans out the selector switch, and I'm going to show you why. But let's talk about this resistor that will, if it burns up, if the tube fails, will clear out the meter. And it's right here. It's an 8.2 ohm resistor. And this looks like a half-watt resistor that somebody has already changed. That's a modern film type resistor. So there was an incident that would have caused the original resistor to burn. But thankfully it didn't take the meter out. So the fix for this is really simple. I mean, 6146s can go bad. You have to expect that. So I've ordered a pack of 5 watt 8.2 ohm resistors. Now this is a shunt. So this is kind of sort of very important that we stick close to 8.2 ohms for the meter to be accurate. So I've ordered a bag of 5 watt 8.2 ohm resistors, but the tolerance is 5%. And I've also ordered a bag of 3 watt 8.2s, but their tolerance on them is 1%. So I'm hoping that in the bag of 5 watters, I'm going to find one that's pretty damn close to 8.2, because I'm going to put a 5 watt resistor in there, and if the tube ever melts down again, it's not going to take the meter with us. Another thing we're going to do is we're going to put a couple of 1N 4007s across the meter, one pointing to the positive, the anode pointing to the positive, and the other one pointing the anode to the negative. And that doesn't let the voltage rise above 0.7 of a volt at the meter. So it's another way to protect the meter. So we're going to be implementing those. So let's pull up the schematic and talk about what's happening at this wafer switches. 2 modifications have to be made before we turn this radio on. But I mean, of course, we've got all the capacitors and whatnot to do and the resistors to go through. And we have, instead of having like a 5Y3 or a 5U4 rectifier tube, Heathkit has decided to use more modern diodes. And these ones are looking so old, I'm probably going to change them up as well. Here's another capacitor here that will have to go, and there's another CAN capacitor here that I will change out. But other than that, this looks like a go, I would say so far. That I don't see anything that's going to stop us from restoring this. I'm very happy. Again, it's very common to see that this ceramic band switch here, it goes up to the tank circuit. Sometimes they make these leads too tight, or somebody pulls on it and that ceramic wafer breaks. And as I said before earlier, the selector switch burns for a couple of reasons. And let's look at the schematic, and you'll see exactly why that switch burns. And I'm going to discuss exactly how we're going to fix that. So if you're enjoying our series of videos, maybe I could ask you to subscribe. That would be great. We've got many other interesting things coming up this winter season for you to look at, and many other restores. So if you could subscribe, I'd greatly appreciate it. So we're looking at here right now 6146 final tube of the DX60. And here's the not a very good mouse pointer on this program. Uses a hand. I hope you can all see that. But here is the 8.2 ohm resistor at the base on the cathode. It is a shunt resistor, and as you can see, when you slide the meter switch into the plate position, if this resistor goes, then all the current going through the tube will seek to go through the meter, and we certainly don't want that to happen. But so by placing a high wattage resistor in there, the likelihood of the tube taking the resistor out is very low. And then we'll put the 1N4007 diodes across the meter for additional protection. So that should look after that and protect our meter. So let's move on and look at this situation here with the switch. This is the function switch that burns out. Let's look at the 120 volts connections here on pin 12 and pin 11. When you first, and this is these fine little tiny contacts on these little wafer switches. I don't know why they did this, but they did it. When you first switch it on, some people who have replaced fuses on their DX60, they've got this hokey circuit breaker that kind of sort of fails. So people take them out and they put a regular fuse in. But when you first turn it on, I've heard stories of people blowing a 3, 4, and 5 amp fuse just while the transformer core gets up to saturation. And that puts a tremendous amount of load on that gentle, sensitive little switch. So I can see why those two contacts would burn. So my solution to that is to use what's called a thermistor inrush current limiter. So I'm going to put a little device in the 120 line that's going to limit inrush current to 2 amps. 2 amps will not be permitted to draw, and that little contact should be fine at 2 amps. So I'm happy that the contact is okay on our 60, and I can clean it up, and I can put a inrush current limiter somewhere on the hot side of the line in here prior to the switch, so that switch never sees more than 2 amps. So it might take the transformer a couple of more milliseconds to come up to temperature, so to speak, or up to voltage, but that's not a big deal. So that's the first thing that has to be done, is there's a lot of DX60s out there with that part of that switch burnt. Now, similarly, on pins 4 and 5, they're actually switching high voltage, 260 volt AC, off and on, depending upon whether you're in standby or you go to AM or CW. When you switch that on and you turn on high voltage and it gets rectified through the diodes, it has to charge these capacitors. So again, that's another big, huge inrush of current, and that's a huge problem. And my solution to this one, you can do two things. If the switch contacts are burnt, well, you can probably maybe salvage them and put a relay in, which isn't hard, and maybe like a voltage doubler I did on the DB22A project. But since my contacts are still okay, what I'm going to do is I'm going to put a 5,000 ohm, a 5K resistor, 5 watts across pin 4 and 5. So what that's going to do is that's going to keep alive that part of the circuit, not fully, but it's going to keep the capacitor just charged so that when you go and come out of standby mode and go into transmit, that those capacitors don't have to charge from the ground up. They're already pre-charged, and it takes the load off those contacts. So that's what we're going to do. So those are some of the absolute. There's lots of modifications we can do to this transmitter to make it better. Everybody out there has got an opinion as to how to deal with this. But I mean, between the resistor at the base of the tube, the diodes at the meter, the inrush current limiter, and the 5K keep alive resistor, these are things you must do to preserve the parts and pieces on your DX60 that are not easy to get or are virtually unobtainable now unless you get a scrap radio. So I hope that clears that up. Actually, I should point out something here. A couple of things here extra. If you note that the hot wire, I assume this is hot, comes in, goes through a switch, and then hits a circuit breaker. That's wrong. First thing that your hot lead's got to come across is a fuse. So I don't know if anybody else caught that, but that's not a great way to do things. So we're going to fix that as well. And you might say, well, if you're going to put a 5K resistor across pin 4 and 5 and partially keep that high voltage circuit alive, won't that put high voltage into the circuit all the time? Well, yes, it will, but only at very low levels. Some people have just absolutely soldered pin 4 and 5 together and had voltage on, high voltage on all the time, which isn't necessarily a bad thing because the radio isn't switched into transmit by high voltage. It's got grid block keying. So in some of the formative stages of the transmitter, in the buffer, in the oscillator and whatnot, a negative DC voltage is applied by this circuit here that does not permit them to transmit until that voltage is removed and grounded. So having some high voltage on really doesn't matter. So you could just solder the two together, but my fears is that would just cause transformer heating. So my idea of just having the 5K resistor in there to keep those capacitors charged all the time without stressing the transformer, I think is kind of sort of a nice happy medium. So we're going to go back to the bench and we're going to check on some of the tubes and see how the tubes are and start making up a list of all the bits and pieces we need to make this old girl fly again. Well, lo and behold, all the tubes test okay. The two 6L6s aren't the best, but they're acceptable. If the transmitter works great, I may replace them, I may not. They're kind of sort of in that zone that they show a little bit of wear, but they still are operational. Similar with the 6146, shows okay. So we can probably trust to start up with these tubes when we get to that point. So that was a nice surprise to not have to replace any of those bad boys. Okay, we're going to check the power transformer now. I have cut the diodes. So there's no DC rectification, so we're just going to measure the AC coming out of the transformer and make sure it's okay. We're doing high voltage first, so we should see 250 to 260 volts here on our cheapy meter. We turn the power on, and we're seeing 260 volts right off the bat. That's not bad at all. So I'm going to set up and we're going to check the 110 volt bias winding in just a second here. Okay, so we're clipped on, and again, I've removed the diode from that circuit, so we're only measuring the AC coming out of the power transformer just to test it. Again, we should have around about 100, close to 110 volts there on this winding. So let's have a look, see, what did we got? Well, that's good enough. We got 109 volts. That tells me that that winding is good. So next, we're going to set up and we're going to check this filament voltage. Okay, we're back clipped onto the filament winding. Again, we should have 6.3 volts. And it's a little bit higher, 6.4, because there's no tubes in it. So that'll pull it down some. That'll be fine. So that's really great. So we've done our initial inspection. We know what's what. We know what we have to do. So I have to go through all of the resistors I want to replace and make sure I've got them in stock and order what I need. No surprises here. I guess the only sad part is the pitting on the chassis. I'll get it cleaned up as best as I can, but nevertheless, we'll put the old girl back on the air. It's clean on the underside. The switches are good. The caps are good. The tank circuit is good. I don't see any reason why not. The primary plate choke is good. I'll probably replace the plate resistor. Just as a side note, you can't put a modern resistor in here because it has a little bit of reactive inductance. You have to put one of the old OX or old Y style resistors in this spot here. So with that, I think I'm going to wind this video up and make my list and check it twice, so to speak. Again, if you're enjoying the series of videos, please take a moment and subscribe. Hit the like button. We would greatly appreciate your support. And we'll see you again in the next one. We're going to tackle into the filter caps in the next one, and the power supply and a cord and all those neat things. So we shall see you then.